Hello, everybody.
Good evening or good afternoon if it's other in another zone. Welcome to Quantum Machine Learning track. This track is a part of the Quantum AI Lab organized by iQafé and Bibliotheca Alexandrina in collaboration with Egypt Quantum Computing Community. We are truly excited to have you with us and to being this journey into the world of quantum machine learning. In today's session, we will honored to have engineering Sama Samir. She will introduce us to the fundamentals and guide us through the key concepts that will shape the rest of this track. If you have any questions, please raise hand and we will answer the question. We hope you join the session and actively participate and take full advantage of this opportunity to explore the future of AI powered by quantum technology. Let's get started.
Hello and welcome to our very first session in Quantum Machine Learning Lab. I'm Sama, and today I'm here to introduce you to the very beginning of the machine learning. I will take you from the very beginning, from the basics of the data science, machine learning, and deep learning, till we reach the quantum machine learning. Today, we are going to talk about the data science in specific, about how we can clear the data, make the observations, and so on. I would highly recommend you to actively participate with me, as the session will go as follows. I will ask some simple questions. I would like you to raise your hand and answer with me these questions. And I would like from you, some of you, to introduce you to me and your background. So we can begin with anyone. Raise your hand. Can anyone introduce himself, please, or herself? Okay, and
hello, everybody.
Welcome. Can you
Yes.
introduce yourself to us?
Yes, I'm Professor Ashraf Solus. I'm a professor at the National Telecommunication Institute. My current job now is Deputy Director of NTI.
Okay, hello, welcome to our session.
Welcome to you. And I'm excited about the course, and I hope that it will help me to go through research using quantum machine learning.
I hope that, and I will be waiting for your feedback for each session. And thank you so much for participation. Who else can introduce themselves? Can anyone else introduce him or herself? Just feel comfortable. We will be talking a lot.
Hello, this is Sameh Nasif. I'm a solution architect currently with Data IQ, specialized in AI. I'm also preparing a master degree in quantum computing, so I'm here looking forward to learn the gap how to apply machine learning within the quantum world.
Hello, and thank you for participation. And I hope you can achieve your goals from our sessions. Nada, go on.
Hi, everyone. Nice to meet you all. Okay, my name is Nara, and I'm a senior student in Computer and Communication Engineering in Alexandria University. And hopefully this is going to be the beginning of my track in quantum machine learning and quantum computing.
Welcome to our course, and I hope you can achieve your goals from it. Let me talk about my background. I'm a communication and engineering. I'm an engineer in communication and electronics engineering, working in AI for about 4 years now. I am a part of an organization that will be releasing AI security platform, I think this week, and I have worked on it as an AI developer, and I hope you can all see it soon. And I have an experience, as I have told you, in machine learning for 4 years. So let's just dive deep. For today, it will be all about data science. We need to figure it out, so it is the key for any machine learning and deep learning model. The key is about the data. It's not about the model. It's not about which technology to use. It is about how the data fits our problem and how we can drive the solution from a model. So let's begin. First of all, our session objective will be, at the end, is the ability to understand how data is really represents, identify the different types of data correctly, explore and visualize the data sets effectively, engineering meaningful features, reduce the dimensionality while preserving information. And for this session and the next session, we will know how this really affects our model as a machine learning, and we will continue in this way. Is there any questions till now? Okay, perfect. Let's go on. So the first topic we are going to talk about today is data science mindset and data types, which is the most important thing in data science, to know what is the data we are working with. Is it a categorical data, a numerical data? What will this affect our model? How? What we must think when we see something. Let's say that data science, it's about the intuition, the mix of the intuition and the knowledge of how to deal with this data to gain the most effective mindset, or to gain the most effective thing to come to the model or come to the solution. So the first question that we can ask, what is data to you? Raise your hand to participate. What is data to you? What does data means to you? Go on, Ahmed.
Well, data is it's a representation of an actual situation or something that you need to deal with. So in principle, some representation, you know, of some actual identity.
Yes, that's perfect. Okay, who else can give us another answer? Okay, Marcel.
Data maybe means something that is collectible. It can be voice, it can be text, it can be picture that we can fit to a model to train on.
Okay, that is perfect too. But here, let's think about the data as the meaning of the data. Go on, I can't hear you well. You have an echo in your voice. I can't hear you well. You have an echo? A very loud echo that covers your voice. Okay, George, go on.
Data, I think it is everything computers can understand to perform a specific task.
Okay, that's perfect too. Yani, most of your answers is correct. Data to us is about, when we say data, I doesn't mean that the Excel sheets or the tables or the things that I fed the model to. It is the collection of the observations about the world. Either it's a number, either it's an image, either it's something like a vector, a series of numbers, or so on. An observation for us is the one thing that we are studying. Is it a person, an object, an event, a moment in a time? Depending on the problem that we are dealing with, the data differentiate. And we must determine what is data to us in each problem. Each problem in machine learning differentiate, and it has a lot of meaning. So our goal is to reach the exact meaning that we need. We can work now in on the same model with the same architecture with the same data, but each one of us will get an observation different from one another, because each one of us sees the data in a different form or manner, or each one sees the data from his own eyes. So our goal is to see the observation that the model will need, or the real world is talking about, not just all of the observation inside one person. One person can have a lot of observations. We can observe its personality, we can observe its career, we can observe his lifestyle, we can observe many features in the person, in one person. So the goal is to determine which specific data type or which specific data I need. I'm making a model about or I'm making a machine learning about careers. So I will focus on the observation of the career of this person. What is his experience? What is his future work? What is he currently working on? And I will leave all other data behind for an object. Is it an image? So what is inside the image? For an image, we will have many observations. We can see a sky if we are in a landscape and trying to take a picture. If I'm trying to make a model to see the houses, or to observe houses, or to generate image generator. So the object here, we are searching for a house. So we are not we are not seeing the sky. We don't mind to see it, but we are focusing on the main object of the data. So data for us is the observation about the real world. In specific, in machine learning, we are talking about the observation of the data inside our problem. And as I have said, each one can see another observation that the other person sees. So make sure to see what is the observation needed for each kind. So the question here, why I said data, not tables? As I'm talking in machine learning, and most of the data we are working with is either a tabular data, an image, or a vector, or something. So why did I say data, not tables? Can anyone help me in this? But don't read from the slide, please. Go on, Manna.
Can you hear me?
Tell me, can you say?
Can you hear me?
Can you just make? Can you just make the microphone from your mouth, please? What?
My microphone.
Say it again, please. I can't hear you well.
I can tell you to the chat messages. So I fix my microphone.
Chat. Okay. Yes, you think what? I can see the chat now. If you have any questions and you don't want to raise your hand, you can send it in the chat, okay? So let's just continue. For us, a table is just a representation of data. Data because Minna says that data because there is a multi types of data in the like images, voice, and something like this. Okay, yeah, there is a multiple type of data in the something in an image or an audio or a video, and I can represent it in a table. Actually, if for an image, I can take the number of the pixel of each image and fit it inside a database, inside tabular data, inside a data frame, or inside a vector, so it can be fitted inside. I guess because tables aren't full info. It is existed before, right? Table is about the observations that we have seen. It is, you can say it is a passive data or a passive thing. So before the table existed, we must think what has happened before the table existed. The table is created because something happens, or something happens in the past, or we can say an observation that we have seen, so we need to record it. So before the table exists, we have a patient exists, so we make the medical records. We have the customer exists, so we can make the customer data or the score payment for a bank. An event happened, so we take the observations from the event. A table is only a records of what we observed. Okay, I'm not talking about the actual data. The table is contains of a row and a column. The row here is one observation to me. Columns here, it is the attributes of the observations that we had. So if we can say, if I come here and say that row 1 is for Sama, what Sama have? We can make a properties. Sama have a brown hair, dark, say a mid-tone skin. We can say this is 2 column, 3rd column, the way of her lifestyle, and so on. Her old, from where, when, and like this. So for each one observation, we store it in a row. And for the column, it is the properties or the attribute. How old, from where, when, how much, and what type. And take care that the tables is different between each problem and another. And take care, again, from the observation you take from the data. So now let's go to the data type. Data type, we have 2 main data types. We have the quantitative data types and the qualitative data types. We have under the quantitative data types or the qualitative data types, we have 4 other types. We have nominal, ordinal, interval, and ratio. This data types is used to describe the nature of the data being collected, analyzed, and help to determine the appropriate statistic test. So take care, when you observe some kind of a data, either it's a qualitative or a quantitative, we must know the statistics test we are going to use. What libraries? If either in the visualization, I will use a scatterplot, a histogram, or a pairplot. What would I use inside this to make the visualization correctly? Is it a linear data, so I can use a linear plot? And how we are going to visualize it. So for this part, we are going to talk about the qualitative data, which is the categorical data. Data is categorized into various of categories. Okay, the categories here, we have observation on 2 groups, which is not comparable, as male and female, as male and female, as we can say, I don't think it's appropriate to say right and wrong, but for now, we can say right and wrong, 0 and 1. We don't have to compare it. It is a solid thing. It is just, you know, the east from the west. You cannot say the east is a west, or I consider it as a west or something like this. No, the east is the east and the west is the west. So we here talking about the data groups, which are not comparable to us. Ordinal data. Ordinal data here, we are used to measure attributes or opinions, whether you like meat or not. Some people will say, yes, I like meat. Others will say, no, I don't like meat at all. So we have an opinion in this. We don't negotiate we can negotiate in it. We can say our opinions. So this is a natural order of responses. We can say it as the rating inside an application. This person likes the product too much. This person says, no, not at all, it's not useful, and so on. So it's an opinion. Then we can go to the quantitative data, which represents a numerical value. The numerical value here, we can say it has two categories, which is discrete and continuous. And the difference here, that discrete values is a single value. We can say like a whole value, discrete value. Continuous value, we can say it's quantitative, continuous range. As for discrete, we can say the house prices. It is a discrete single value. For continuous data, we can say the audio. The audio has a continuous range, which varies according to the audio tone. If it's so high, if it's so low, and so on. So is there any questions here? Feel free to ask in the chat.
No, it's already right.
Okay, perfect. Then we are going here to talk about the second thing. It is the data quality and the integrity of our data. Why does EDA exists? EDA stands for exploratory data analysis. So can you help me here to say, why do we do EDA in machine learning and so on? Go on, Marwan.
EDA is useful to get a sense of how the data looks like, or to define whether I have what kinds of manipulation that I need to do for the data to be ready for my model.
Okay, perfect. So we can say here that we can take the main observation that we will need for a problem. And go on, can remove outliers and filter unwanted data. Yeah, in EDA, we filter the unwanted data, but this is, we can say it is the very last step in our data, in our EDA, if it's needed. So outliers and filter the unwanted data can be very useful in specific applications. But if I'm going to talk about a payment in a bank, the bank get me a data to do an EDA. So we can find many outliers, because some the banks, we have businessmen, so they can insert money with millions and withdraw money with millions. So here outliers, removing outliers or unwanted data will not be useful at all. So anyone else has any opinions? Okay, let's continue. Okay, who raise your hand? Go on. Who raises his hand or her hand can go on and speak. Okay, we have some here. Make us understand the data. We deal with better than just with, yeah. Yeah, I will come and explain more now. For the ADA process, let's talk more about it before getting into it. The ADA process, or the exploratory data analysis, exists because we can say that the tables or the data we have does not doesn't give us the observations we need, does not give us the pattern we need for the model. So again, if I'm in a bank, the bank came to me and said, hello, we want to know who are most likely to go away from our bank and who is the most likely to stay in our bank, and I need to do an analysis for the data. What we have here is what? They got me a table. Okay, this table is about, we can say it is about, it gives us the age of the person, his work, how much money he withdraws in a month, his payments. He gives us how money does he get in a month, and so on. So from this table, can I know who will most likely go and stay, and if there is a fraud going on here or not? From the data, I don't think so. We can see it from the very beginning. Yes, it's a no, because it is just a table, an observation, or we can say it is a passive thing. Here, I will need the exploratory data analysis. The exploratory data analysis most likely go into two parts. The first part is the statistical analysis, where I see the statistical relations, the mean, the mod, and we are going to talk about it. The mean, the mod, the median, what is the shape of the people using. ADA stands for exploratory data analysis. It is about analyzing the data in two ways, visualization and statistical. The statistical helps me better understand the numbers and how it related to each other, who affects who are most likely to go, the mid-aged persons or the teens or the elderly persons, who are most likely to have a fraud on, and so on. The visualization make us see the patterns more clear, where we can visualize everything. Okay, then we are talking about the key processes. Now we understand what is ADA and which are the two main parts in it. The key truth that the model does not fail first. Data fails first. Go on, someone is going to talk? Okay. The key truth again, that the data or the model don't fail first, but the data fails first. The key solution for any machine learning problem is the data. Which data you have chosen? What observation did you get? You can get the most meaningful data in the whole world, but with a bad ADA or bad exploratory analysis for the data, the model will fail. Although you have the best data, but the model will fail. So the key is the data, not the model. ADA process is about understanding the data, questioning the data, stress testing the data. And here some things can work under intuition, where you can say this will work or this does not work. And what makes you sure of this is the analysis. From the very beginning, we look at the table and we most likely trying to see the relations between the data and each other. Then we do the exploratory data analysis, questioning, understanding, stress testing, seeing the results, seeing the statistics, and then we take the decision to move on or dive deeper in the data to discover more patterns. First of all, the exploratory data analysis is the missing values. So missing values to us is about the data that was never collected. This can be an error in a system at some point. This means it can be some mistypo or some misinserted data from a human. Sensor failure. where if I'm working in an environment that a system that collects the sensor readings, the temperature, humidity, and so on, sometimes the system can fail, or it can replicate, or can get an error. User refused to answer. This is most commonly in teleperformances datasets, where the user refuses to answer a specific question or so on. So the human that is working on, or the person, most likely don't type anything. Value is not applicable. We can mistype an integer to a number or so on, so the value is not applicable to the data, or a system error. So how does we know the missing values? We know it with two things, which is df.isNa.sum. Isna is for is null. Is null here means that the value here in this row, in this column, is empty. And it counts how many values is empty in each row. Then we have df.isna.mean. Isna is null again. So is there any questions here?
No, it's okay.
Okay, perfect. Then we are going to talk about duplicates. Duplicates comes from logging errors. For a system, we have a logging error. A logging error where we take the logging info or replicate the data and so on. Sometimes it's a multiple data resources. Go on. Who raised his hand? Go on, Ahmed.
What are these codes? Yani, I don't understand how these codes are related to what we are discussing.
Now, after we have finished, we will go through a very known dataset, which is the Titanic dataset, and I will make sure that is this type of codes related to you in the dataset. But this is, you can say, the common code. Okay.
Code for doing what?
This code to know the number of duplicates. And the code in the previous slide is about the code to know the number of the null values, or the missing column, or the missing property in this column, and so on, for the whole table.
Why is the code formulated in this way? What is df?
df is the name of the dataset. You can remove df and say the name of the dataset, and I will walk you through it step by step. df, it is just a name. We can say sama.duplicated.sum, ahmed.duplicated.sum. It is about a name. df, it's a name. But the main features here is duplicated and sum. This is the main. This will never change. But here I have named my data df. So it is always df in the whole data.
Okay.
Okay, perfect. Ala?
Yeah, will we have like a lab session like after this, or it's just lecture and so on?
Ask again, please.
I'm sorry, you can hear me.
Yeah, I can hear you.
Yeah, I'm saying like we will have like lab sessions, or it mostly will be lectures.
No, we will have a lab. You can give me about 3 minutes, and we will have our first lab.
Okay, thank you.
You're welcome. In duplicates too, we have the system retries, where the system first for a few seconds and retry and retrieve the information, so it duplicates it, and the human data entry. Then we have the two most common things, outliers and errors. Outliers is about the real possible values. What is the possibility that one person a day will withdraw $1 million from a bank? This is very rare, actually. Impossible or invalid values for errors. So we can say outliers is a rare thing, but it's possible. It can be. The errors, it is about the impossible and invalid values. Relation to reality. Outliers can happen in real life, as a person can withdraw $10 million in a week. It can be if it's a business. Errors, it cannot happen in real life. There is nothing like this. For example, a salary of 6 figures or 1 million, an age of -5. So there is a difference between an outlier and the error in a data. The cause of the outlier, it is the natural variation of extreme cases. But for errors, it is about data entry errors and system bugs. Then we have the action, investigate data before deciding. For outliers, we have to determine what is our problem, what is our approach, what do we need to approach in the very end, or the solution that we need to have it at the end. According to this, we decide either remove the outliers or leave it, as I have said, in a payment system. Errors. You have to do two of things. Either fix it or remove it. For errors, if the outliers is mishandled, so it gives us a losing important signal. It can make the data overfit, very overfitting. Usually outliers does not make underfitting, but it can be. Errors, which is a corrupting analysis. The analysis from the very beginning is wrong. So let's see the questions. We have a question inside the chat. Okay. Is there any question here? Go on, Marcel.
Why outliers cause overfitting?
Outliers cause overfitting. So let's say again about the payment system. Let's think about it. We have 3 categories in it: teens, all adults, and elderly. Most likely from teens to adults or elderly, we have like they withdraw like $150 or 50 pounds per day. They have an average salary of we have an average salary of from, we can say, 10,000 to 25,000 for teens, and the average increases. So outliers sometimes is more useful to us, and in other times it is very bad. So most likely in other systems, we can say in determining the age of the people, average people in Egypt. So we can say that how many people are above the age 90 or 100. You will see it rare, very rare. So if the data sees it, it will consider it, and if it consider it, the model will try to reach this peak. So it is most likely will try to get all of the points inside the data, which is from age 1 to age 100, and this will cause the overfitting. And we can say that we have about 10 people in Egypt that is above 100 or above 90. So sometimes outliers can be very bad to us. Ahmed?
What is overfitting?
Overfitting means that the model trains a lot and he knows most of the patterns. So if he sees a new data, he will most likely try to retrieve it all rather than make a reasonable decision in it.
Not clear. Actually, not clear.
What? Can you tell me again what
This
did you say?
is not clear to me.
This is not clear to you. So give me an example.
Outliers.
We have talked. Look,
something that rarely happens.
Outliers is something that has really happens. So if I'm
Okay.
talking about a person that is more than an age 90, and I'm seeing the model here is seeing the most the average number or the average age of people in Egypt. So what will happen that the model will perform very well in training. You have get them the extreme rare things or the extreme rare age. You have given them the normal. So it will train very well, as you can say that he has known the textbook from the side to the side. But when he sees an unseen data, what he will do? It will poorly perform on the unseen data. The data he never sees, he will perform very bad. It is mostly happens in noisy data over outlier data with too many outliers unneeded or unnecessarily, or for training too long or so on. So this is why overfitting happens.
But including the outliers actually gives a more realistic picture of what really happens.
According to the problem that you are solving. As I have said, if I'm talking about a payment in a bank, yeah, it is most likely that a businessman is withdrawing now $10 million. It is possible. So outliers here is most likely we don't remove it. But if we are talking about the average person age, most likely we will remove the outlier here, because it will affect the data in a negative way. Our goal here is to give a reasonable model, a model that works in a very fine way, that give me a reasonable decisions and a reasonable answer, not the extreme answer or not a poor answer. Okay?
And it depends on what you consider reasonable.
You consider it according to your problem, to the problem that you are solving. Overfitting means that the model memorizes the data very well, yeah, and cannot, yes. If there is an outlier, it means, yeah.
I don't see the chat.
It will be at the side of at the left, bottom left, right side. If there is an outlier, it means I don't have to clean the data or not. According to your problem, Fatma, if you see an outlier, ask yourself, what is the problem I'm solving? So do I need this outlier or not? If you need it, you can make it. If you don't need it, you can remove it. And we have a way to determine it called IQR, and I will talk about it later again. But for now, I don't think so. It is according to the problem. Ala?
Yeah, can we move on, and then we when we have the real data, we can actually talk about this?
Yeah, that's perfect.
Yeah, thank you.
Then we have the noise and the signal. There is a very big difference between a noise and a signal. A signal is a random variation that don't have a pattern. Sometimes it is from 1 to 100. Yes. Who's talking? Go on.
I think you're talking about the noise or the signal.
Now we are talking about the noise and the signal. What is the difference between a noise and the signal?
Okay.
Okay. Now, for a noise is a random variation. Let's say I'm at this moment at point 1, and the next I'm at point 100, and then at point like this. It is a random variation. It is like moving in a random position. But for a signal, it has a meaningful pattern. It is like accelerating a car from 0 to 100 in 3 seconds. Information value. Noise have no meaning. You can see it at some point at 100 and the other point at 0, and so on. Signal represents a real behavior of data. Stability changes the unpredictable. Noise changes the unpredictable. signal, it is consistent, has a structure, and we will see it in our data. So let's move again. We have other ADE processes than knowing the data types. Data types and its meaning, and we have talked about it. The value range and its constraints. It is about the outliers, real-world limits, the impossible and suspicious values, or the domain knowledge required. Then we have the distribution shaped, or the symmetric shaped with skewed, and we will know what does this mean. Categorical or cardinality, which is the unique values. Inconsistent table. Inconsistent tables does not mean that there is a noise, but means that there is a gap. Human input is messy, and sanity checks, shapes, rows, columns, and so on. So here, let's begin in our very beginning lab, which is the Titanic dataset. For the Titanic dataset, you can download it from here, which is the Kaggle. A Kaggle dataset, and here we can know more about the data and what is for. This data is about the sinking Titanic ship, which is have made the most famous film. It was in April '92, and you will see here some info about it. Then we will go to the important part. The important part here is the columns that we have. We have the passenger ID, survived the P class. Which class? It's if the ticket was class 1, which is the highest class, class 2 is the mid class, and third class was the persons or the people that were at the bottom of the ship. The name, the gender or sex. Then we will have, let's go right here. Then we will have a sibling, if this person have a sibling or spouses. Porch, which is if the person have a parent, children abroad in the Titanic, the ticket, and the fare, the passenger fare. Okay, and you can download it from here as a zip file. Okay, let's go on to our next step. Is there any problem in this tab? Okay, first of all, here I'm using Visual Studio Code. Okay, and Visual Studio Code is one of the most powerful tools. I think most of you have come to it. But for people who didn't come to it, here I have created a folder, a normal folder on my computer that called session 1, and I have made a new file. The new file, I give it a session. Okay, .ipynb, and ipynb is the extension of Jupyter Notebook. Okay, and I have created a virtual environment too. The virtual environment here I have created by this command, which is python mvenv.venv, and we can install all the dependencies that we want. As the first dependency that we will need is NumPy. NumPy here, it is a Python library that is responsible for, we can say, the mathematics, the calculations, and so on. And we will press enter. Okay, and I will say create. Here, the creation here, I am choosing my kernel. Okay, we can select kernel from here, Python environments, and choose the environment that we need. And it will work as pip install NumPy, and it will be okay here, defaulting user, and so on. So NumPy here, it is our very first library, which is again responsible for the math or the equations in our dataset. Second thing, we have the pandas. Pandas, it is mainly used to load your data inside this notebook and will help you more to just see the data frame and so on. Pandas, okay. So let me get back to Google Meet. Okay, Ashraf, go on.
Okay, do we need to follow you in this session, or to follow you going through these commands on the Visual Studio Code, or
Yeah.
we can find this on the resources at the classroom and practice individually.
You can do both. If you want to follow me, open your Visual Studio Code and go on. If you don't want and you feel like you want to concentrate in each step will be uploaded on the resources, the 2 datasets I will be working on, the tasks, the slide, and everything.
Okay, thank you.
You're welcome. So now we are going to install pandas. So what is pandas to us? Pandas to us, it is a very powerful tool. Okay, it is used in data science and machine learning and so on. It is used to read our files, which is most commonly our files are .csv, which is comma separated value. Comma separated value is that each column is separated by a comma. It can read SQL, Excel, and JSON. It cleans the messy data if there is any missing values or a messy data set and so on. Filter the rows and columns, handling missing values, and it also perform statistical analysis. So we can go again and say pip install pandas inside our van, and it will be installed. Okay. Last, go on. Who is asking a question?
So do we have to have Python? We have to have some experience with it?
Yes, for this course you have to have an experience with Python, since Python is the main you can say the main star. It is the main star.
Main star for what?
The main star of machine learning. We are using it in everything.
Yes, but it was not said. It was not said that there is a prerequisite for attending this kind of course.
Okay, you can go along with me, and I will try to clarify everything, and I will upload resources for Python specifically, so you can go along with the course.
Okay. Okay, thank you.
Okay, perfect. You're welcome. So now, as we have installed pandas and NumPy, we will begin. The very beginning of our code is by adding a code. First of all, we need to import our used libraries. And to make your code more clean, just leave the first step to import any libraries you need. So here we can say, first of all, I need to import pandas. So I will say import pandas as PD. Then I can import NumPy as MP. Then we will use another, you can say some kind of another dependencies, which is matplotlib.pyplot. Matplotlib.pyplot, it is one of the most famous libraries that is used in visualization. Pip install matplotlib.pyplot. Okay, sorry, this is my bad. This is a dot. Okay, and it will install it and go on. I have the version. Then we will going to install the other dependencies that we have. And we will go on as this. We can say matplotlib as pyplot and import seaborn as CNS. So can anyone tell me more about these libraries if you know? Go on, George.
I know Matplotlib is for data visualization, but I don't know Seaborn.
Okay, perfect. I will tell you now. We have Marwan. Go on.
You've already explained both pandas and NumPy. NumPy is
Yeah.
empty set for numerical calculations. It's written in C, so it's very optimized to be fast. Pandas
Yes.
is for loading the data into the memory in data frame objects. Matplotlib is for visualizations, and Seaborn is for more sophisticated visualizations.
Yes, perfect. This is more than perfect. Marwan, go on.
Okay, as my friend said, that was for the mentioned libraries. Just a little more library, which is important also, which is scikit-learn. Scikit-learn is an important library. It will come the next steps maybe in the, after making the
Yeah.
pre-processing part in the models that are built. So that's what I wanted to add.
Yes. Yes, perfect. Scikit-learn, we will use it. We will use it in many things, as we can use it in the model preparation, normalization, and so on. But this is, we can say, a very advanced thing, so we will get to it soon. Okay, so let's continue. I think my share screen has stopped. Give me a second. Okay, here we are. Here, here I have installed pandas. Then I will install matplotlib.pyplot. And don't forget, it can get this error, which is the version could not satisfy matplotlib. Okay, this is a very common error in, we can say, Python code. And it can be solved with identifying a new kernel or so on. So let's go on in the main data set again in Kaggle, and I will give you, you can say a minute. So you can see, you can determine from just the rows or the column names or the properties that we have, what we are going to use, which one is important to us and which one is not important. And I think most of you is familiar with Matplot, with Titanic dataset already, and there is many videos for it. So from the names of the Titanic dataset, what do you see? Which columns are important? Which columns is not important? And you can say your observation if needed. Go on, Marwan.
The name.
What is the problem with the name?
I think your question was if there is any redundant feature.
I'm not asking about specifically the redundant feature. I am asking more about what do you think, which first feature are not irrelevant? We can remove it. So again, ADA analysis or data science mostly depends on the problem and your intuition. And here the problem that I need to know which people will survive and which people will not survive from Titanic. Most likely survive and most likely will not survive. So go on. We have Marwan again. Go on. Okay, we have Marcel. Go on.
Survived is crucial. I guess this is the target for us. Name, we don't need it at all. It won't help us with anything.
Okay.
Pairplot may be useful, so we can use it. Passenger ID, it may be helpful if we use it as an ID أو something unique, whose IDs are not repeated.
Okay. Marwan, go on. Thank you.
Okay, we may talk about the less categories. For example, for starters, we may say that surviving is the most valuable.
That's what? Your voice.
And beside,
Your voice is so bad. I can't hear you well.
is it clear now?
Can you hear me well?
Yes. Is
Yeah.
it clear now?
Go on.
Okay. I'm
Yes.
saying the most category, and the less relevant may be the passenger class.
Okay, perfect. Okay, the passenger class. We will talk about it now. So that after we have installed our dependencies, we will run the first cell, and you can say that the privilege in Jupyter notebooks and so on, that each cell runs independently. So if we have an error at some point, there will no the error won't affect the other cells at all. Okay. So this is one of the most important things in it. Then we will begin to, I need to load it. I need to load my data. My data is Titanic dataset underscore CSV. This is the main thing. First of all, we will get the name. We can say that the common name is df equal pd dot read underscore CSV. So let's say that read underscore CSV is about reading a CSV file. So if I want to read an Excel, we can say read Excel. Okay, we can say read table, we can say read SQL table. So this is according to the type of the data, and we know it from the extension right here. So we can say read underscore CSV, and we will enter the address of it, from where we can get here, say copy path, and implement it here. And here we will find that our data is loading. So I have an error. Okay. I know what is this error. So let's continue. So the first of all, we are going to read our data. It is like read underscore CSV. Okay, let's continue now, and I will solve this. Then, after loading our data, we will be focusing on we can say we will be focusing on, now we need to know the shape of our data. We need to know what? The shape of our data. The shape of our data is one of the most important things we can see. Because let's tell you what, the number of the features inside your data and the number of the things that we have inside our data is the most important things that we can use. So let's, I think, go on a break for a 5-minute break, and we'll come to our lab so I can solve this error. Okay, can everybody hear me? I have solved it. Okay, let's go back. Can you raise your thumbs if you are here, and let's continue. So my error here is sometimes from the dashes and the spaces, it comes to an error. So the solving for go on, Fatma. Fatma? Okay. So for this error, we can go and do that OR thing that I was trying to do, but it's okay. So after loading the data, you will see that nothing happens. Literally nothing happens. So our goal now is to see the shape, the data, how it goes on. And we can say from here, we will work with the data as a whole, or we will work with the data as a data frame which is, you can consider a table. So after loading it, I will need to see the features that I have, the properties, and so on. So now I will deal with the data as a name, df.head. This is the first thing. Head means give me the very first 5 rows and its observation and properties. We can here say 10, 20, 50, and so on, and it will work. This is for reading head. And we have another one that is called tail. We say get me the last 5 rows, the last 20 rows, and so on. So when we run it, we will find our data. So again, our goal here is to say if the person is most likely to live or what, or no. So again, we have the passenger ID, survived, P class, it's their class, their name, sex, age, if they have siblings, if they have if they are parents, have children, and so on, the tickets, fare, cabin, and embark. So again, I will ask the question, if I want to know if this person survives or not, which is the most likely columns to remove? And now you see all the columns that I have. What are the most likely columns to remove? Go on, Marcel.
I don't need the ticket number.
The ticket number, okay. Perfect. And what else? Marwan, go on.
I think the fare is not that important.
Fare is not that important. Okay, perfect. Marcel, go on.
Cabin has lots of non-values, which is undefined. We can remove it.
You don't know if it's have a lot of non-values or not, because you are seeing just the very first rows. The first 5 rows, and I don't see. Oh yeah, the cabin nan. Okay, so most likely when I see something like this, I will most likely see that the passenger ID is not important. The ID tells me we have 3,000 persons on the ship. That don't describe if this person is A class, B class, C class. So most likely I will remove the passenger ID. And also the name. The name of the person is not important. The important things is the class, his sex, age, if it has sibling or not, the fare that is have been put inside of it. Okay. So now let's not rush in removing these columns. Minna, go on.
Okay, I will say the name is not important for now, but if I get the model and the prediction, maybe I can match the output of being survived or not survived with the row to match the if the customer needs to know which names actually survived, I can return back to the data and match it with that row or that passenger ID or maybe the target. But for now, I don't know the name, like no string.
Look. My target is to know if this person survived or not, which is the most important column here is survived. And the passenger ID is not anything to me rather than a number. It is just a number that describes that this person got from me a ticket from the booking ticket venue or something like this, and so on. It does not means anything to me. And if I get this data to the model will most likely fail, because as Marcel has said, it has a a non-values, and you are actually saying that the data is you can say it's not that important from the very first 5 rows, and I need to see all the rows. It contains more than 7,000 rows. So I need to see all the rows. I need to see the effect first of this data and then decide. Okay?
Okay, thanks.
Perfect. Now we are going to not rush again for removing these columns. I will first do df.describe. The description here will get to me what? The description here will give to me the most likely the mean, the mode, the standard deviation, and so on. So let's see and explain what is happening. So we have about
what does embarked mean? What does embarked mean?
Embarked here in Titanic dataset. Okay, can you hear me well?
Yes. What does it mean?
Okay, embarked in Titanic dataset means you can say the location of the passenger on the ship. You have C for Cherbourg, France, the location that the person have board on this ship. We have C for France, Q for Queenston in Ireland, and C for England. S for England, sorry.
Okay,
so this is
the place where they got into the place where they got into the
ship. Yeah.
Okay.
We have now the count. Okay, the count here, it is the number of the columns or the number of the rows that we have, not the columns. Sorry, we have 891 ID, 891 survived, 891, and so on. Then the mean. The mean is so important to us, which determines the middle of the data. So the middle of the passenger ID is 446. And if you see the relation between the mean and the 50% quartile or the 50% of the data, it will be nearly the same because the ID does not change in the middle of the data. Someone raised his hand. Okay, chat. Okay, someone said embarked and cabin are not important. Statistical description. Yeah, it is a statistical description for the data set. Perfect. So here we determines the relation between the data and each other, or the mean and the 50% quartile. The mean is the 50% quartile, or it is nearly the same. 50% here means the middle of the data. 25% mean the first 25% of the data. 75 means the 75% of the data, maximum all of the data. The mean is our middle of the data. So if you can here see that the mean and the 50% for the passenger ID is nearly the same. Survived, we have about 38% of people survive, where in the middle of the data we have 0% survive. P class and so on. Standard deviation. The standard deviation is how the data deviates in our data. Okay, and we will see it more and we will describe it more. You can say it's a primary description or a statistical description for the data set. I won't say it is not important, but we need to know more. Second thing we need to know is the information inside this data set, the type of the data inside of it, if there is any columns that have any null values. So we are going to say df.info, which is a sort of information, but don't write information, it is def info. Here we can see that the passenger ID is an integer, the survivor is an integer, P class is an integer, name, sex, objects. Okay. And we can see here that the null count, we have non-null. And we have here missings. You can see in the cabin is missing, so most likely I will remove the cabin. And in the edge, we have 740. We have, you can say about 90 and something missing, or 100 and something missing. So here, can I ask a question? Is it good to remove the age from this data set? From your opinion, as I said, that data science or working in EDA is based on intuition. So do you think it will be proper to remove the age? Nada, go on.
I think the age is actually like a really good feature and should be kept because, like, for example, children can be like survived more, like they have a higher chance of like surviving than teenagers or maybe elderly people, like not really more important. So like I think it should be kept.
Okay, perfect. This is a perfect answer, Marwan. Go on.
Okay, I think age is so important for a closer look about the diversity of the audience we are talking about.
Yes, perfect. Do you know that in Titanic ship, most likely the survived was women and children, and most likely they're from the A class and so on. So we have, again, if we go up in the data, we can see that the age is so important and the sex is so important. And you can say the class of these persons. Yeah, it is important. And the question mainly here, how can we fill these null values? Because it cannot be kept. It has to be filled. So now I'm going to see if we have a null values here. From the info, we know that we have missing values, but how? What number is it? So we are going to use df.isna.sum. Okay. So this will determine the summation. Yes, I forgot here the braces. Sorry. Okay, go on. So we have in the edge 177 edges are missing, and in cabin it is 687. So again, most likely I will remove the passenger ID, the name, and the cabin. And embarked have 2, and we will see if we need to remove it or not. After this, we will begin in our fillings. Okay, our fillings here, we have 3 things. So let's get back to the slide and come to an explanation for them, which is what is the mean, what is the median, and how does this affect my filling for the data. As I have said, if you didn't remove the missing values, most likely you must handle it. So let's get back to our slides. Till now, do you have any question? Okay, perfect. Let's go to our slides again. So for our slides here, we are talking about the statistical intuition and how to fill the data and when and with what. First of all, we are going to talk about the mean with the median. The mean is the middle of the data. So if I'm going to talk about the normal distribution, or we can say the bell-shaped distribution, we can find that the mean is equal to the median. For a left-skewed data, where the data were most likely driven to the right side, where the mean will be smaller than the median. For the right skew, we can say that the data will be driven to the left side, and most likely the mean will be bigger than the median. Our goal is always to have a normal distribution. Does this always happens? No. Sometimes you must work with skewed data, and sometimes skewed data can mostly a primary sign that there is an outlier. The mean is the average or the sensitive to extreme values to outlier. So as I have said, you can find that the mean is driven to the left according to the outliers that is happening to the data, or to the right according again to the outliers in the data. And we have the median, which is something in the middle. So if I have 6 numbers, the 7 numbers, so the middle will be most likely the 4th number. So the median is an indicator for the middle value, and it is resistant to outliers. It does not get affected with outliers. So we can say that the median is the center point. We have the normal distribution again, which is the symmetrical shape. You can say the bell shape, which is one of the most wonderful data you can work with, which is the mean and the median. So when I make a visualization, most likely I will go and try to make the data in a normal distribution. And again, this depends on the problem and depends on how you solve the solution and if the outlier is important or not. Then we have the skewed distribution, asymmetrical distribution. The tails pulls the mean, which is the skewed data. The pulling comes from the outlier. Here, again, we can see that the outlier is on the left side, so most of our data is condensed on the right side, and then the right skewed is the opposite. We can see that the data is condensed on the right side, left side, and the mean is driven to the outlier in the right side. Then we have the variance. The variance here, I mean that if the data largely spread along the distribution, or a small variant, the data is very close together. The skewness effect again come from mean smaller than median and so on. So is there any questions about the mean, the median, or the variance? Raise your hand if anything, and you can type in chat. Then we are going to talk about the visualization literacy, the literacy of our visualization. So here we have, you can say, the most common visualization. Is there any other visualization? Yeah, a lot. We have the histogram. The purpose here is showing a single numeric variables, and most likely it is used when you see patterns as a skewness, and the histogram is perfect in showing the skewness of the data. It does not determine the mean or the median, but from your observation, you can determine the mean, you can determine the median, you can determine if there is an outlier or not, and it is a very good observation of it. If we have a single peak, then most likely the data is it has a low variance, it is in a bell shape, and so on. Multiple peaks means that the data is varied across the data set, the whole data set. So it is a very good indication as the exam scores distribution in a class like this. We can say that we can see that we have a gap here. So either the persons are getting from 10 to 20, from 0 to 10, or the persons are getting from 20 to 30. So there's a gap here, and for now we don't know why, but we can see that the data is distributed. You can say it is like a bell shaped. It does not have an extremes. There is no one getting a 50 and there is no one getting a negative sign. And for an example like the exam scores, outliers are most likely an indication of something. So if the value is for a negative number, it is most likely a mistyped thing or so on. So we remove it. But if it's an extreme, if it's the full mark or so on, 2 or 3% get the full mark and so on, most likely it's we will not remove it. Boxplot. The boxplot is another type of summarization, and it has 3 things in it. We have the orange line, which determines the 50% of our data, where the data is split in 50-50. We have the line here, this line here determines the 25% till here, 50, then 75%, and then you can see the outliers along the side. So this one, you can say it says in a straight mouse or something like this that there is an outlier here and you must take care. The purpose here is to, if we want to compare a distribution across different groups or quickly spot anomalies here, I mean the outlier or abnormal behavior in the data, comparing salaries in departments. So sometimes in a company, you can find that the technical developers are getting 50,000 per month, 70, 80, 100. And for the marketing team, they are getting 15,000, 20,000, and so on. So comparing data, most likely we can use a box plot. Determine skewness using histograms. Is there any questions right now? Then we have the scatter plot. The scatter plot. You can say it shows the relation between 2 numeric values, and it can be more. Yes, it can be more according to your problem. It explores the correlation. The correlation means the relation between the data point and each other, the categories and each other, the trends. Where's the trends? So most likely here is a trend. And the clusters. Most likely data from the same group or the same behavior are concentrated according to a circle or a square or something like this, according to your problem again. The possibility of cohesion. Example, height with weight. Sometimes you can see a person with average weight with average height, a small weight with small height, high weight with high height. And for sure, there is some abnormalities in there. Pairplot. Pairplot, it is a visualization of multiple numeric variables at once. I want to see age, score, and so on. We have more than 2 or 3 features. Most likely we use box pairplot. It is when you have a data set with multiple numeric features and want a quick overview about the correlation, the relation between the data sets, the data sets, and the abnormalities, exploring the relationships between the columns and each other. And we have other things. Yes, we have other things. So let's go back and begin with our iris dataset. But before beginning with the iris dataset, I need to talk about something else. For now, we have talked about the mean, median, and so on. So from your opinion, after talking about this, do you think what will be the most meaningful thing to fill the age with? That will really be useful to us. Marwan, go on.
The mean, because it's the average.
Mean because it's the average. Does anyone have any other opinion?
Yes. Yes.
Okay. Okay,
The
perfect.
median.
Let's go with Ahmed. Median.
The
Why
median.
median?
The median. Because it
Why median?
excludes the outliers.
Median because it is robust to outliers. This is a perfect
Yes.
perfect answer, actually. Okay, perfect. George.
Yeah, I have the same idea.
Okay, perfect. So for our problem here, most likely we will be filling it with the median. Why median? Because median here, it is robust to outliers, so it won't be affected with any ginormous age or abnormal age. It will be most likely filling with the middle of the up and the down, and that's okay. The up of the data, the upwards of the data, and the down of the data. So it's okay. I think it will be more than perfect to us. So now let's go to my, you can say, favorite data set, which is the iris. Okay, the iris here have, you can say, the most meaningful, or the most it is the one of the most data sets that you can experience what is the mean means, what is the median means, how does this affect our data set. So for the iris data set, you have two options. Okay, option one is you can load it from Python directly, because it is implemented inside of it in Iris. Or the other thing is you can download the Iris dataset as I have told you before about what? About Titanic, and you can download it from Kaggle. And there is multiple resources actually than Kaggle. Yani don't stick to Kaggle every time you are going to search about a data set you are going to use it. Actually, Kaggle is one of the most useful things to use or to get or retrieve data from. But for more sophisticated or data, or for more you can say targeted data, you can use data from multiple of universities. One of them is the Canadian University, which is have the most valuable DDoS attack data set for security, if you are using for security. So you can download the data from any place you want. So now I will show you something, and then I will download the Iris dataset with you again. So here I can use the data set from scikit-learn. So can anyone tell me what is scikit-learn? Marwan, go on.
It's a library that's very popular with machine learning algorithms, with pre-built fit and train, and it has a lot of transforming pipelines, like the imputers and so.
Yes, that's perfect. Marwan, go on.
As my friend said, it's an exploratory library. It's usually used in evaluation for such, maybe according to the class of the classification we're doing, such as doing the recall, the precision, etc.
Yeah. Okay, perfect. So Marcel, go on.
It contains models, it contains datasets, it contains evaluation matrices we need.
Yes, that's perfect. So scikit-learn, again, it is a very popular Python library for machine learning. It provides tools for classification. If I want to classify people according to genders, regression, if I'm going to evaluate the house prices in Portland, model evaluation, if I want to evaluate pre-processing features, feature selection, and we are going to talk about it, and dimensionality reduction. It is built on the top of NumPy, Pandas, and Skippy or Scipy. It is important for projects like fraud detection, healthcare prediction, sales forecasting, and it has many models inside of it, and we are going to talk about the models in the next session. And here, I have used sklearn, which is the abbreviation of scikit-learn, and I have said import dataset, and I have imported the iris from it. I said iris equal dataset.load underscore iris. This is from again, okay, this is from sklearn. And then we can add a code and we can say iris, okay, iris, dot head to see the data. It's okay. But most properly, yes, that iris dataset inside the sklearn, it is not available for visualization, or it is not a tabular. It is available just for computing something like evaluating a model or so on. So when I load from sklearn datasets, we use iris x equal iris.data. We split it into iris.data and target and use it to evaluate the model. So let's go to iris dataset. I need to download the iris dataset itself. So again, we are going to Kaggle. Let's share my screen here. Okay, I'm going to download. Here's the iris dataset. What does the iris dataset have? The iris dataset is about the spatial lens, the sepal lens. It is iris is a kind of a flower, okay? And you are going to evaluate this flower according to 3 species, which is a classification thing. But we are going to talk about it in the next session. We have three types in it: Stisosa, we have versicolor, we have Virginia, I think, or There are 3 classification categories. So what do you have inside this dataset? We have 150 samples. Each sample have spatial length, the sepal width, petal length, and petal width. So we are talking about the stem and the petal and so on. Additionally, it is evaluated, okay, and the species is written. So my goal here is to make a model to determine this species according to the data we have. So we are going to download it. You can download it as zip or import the code you have here, but make sure that you have Kaggle Hub on your computer. This is so important. Make sure to have Kaggle, again, a hub in your computer. You say pep install Kaggle Hub and you can find some errors again. It's not free from error, but overall you can find it. So let's take our iris dataset from here. Okay, again, we are... do you have any questions till now? Am I not clear enough in anything? Okay, perfect. So after we have put the iris.zip inside our folder, you have to extract it, okay? Don't forget this step, because most likely I forgot it. Okay, After doing this, we will going to do the same as what we have done. We will import, okay, numpy as MP. Go on. Who wants to ask a question?
Yeah, can I do this in Collab better than like download everything from Castle and so on? Or
Yes, yes, you can import it in Collab, and it will be easier to use the code rather than the downloading the zip, and it will be very fine.
okay, thank you.
You're welcome. Okay, we will load the iris dataset same as we have done inside this part, which is PD. Let's make sure that the iris is iris, yeah, the CSV. So we are making it the same from here. I will take it to here. And I'm going to take this part, which is I will copy path, and I will put it inside of here. And you don't have to write the R. You can try to write the path, and if it didn't work, you can try to load it with the R sign here. Okay, I have loaded the data. Then I will say the f.head, and let's see what we have. Here we have our very first five rows again. We have the spatial length, the spatial width, petal length, petal width, and the species of it. And my goal is to determine the species from a machine learning model. Go on. Who wants to ask a question?
Sama, I'm sorry, but I think you're still sharing the Kaggle screen, not the VS Code.
Yeah. Sorry, this is my bad. Here you go. Again, I can tell you quickly what I have done. I have imported my main libraries. This does not mean that there is no other libraries I will be working with. I will run it as long as I add libraries, and it won't affect the other cells in the code. Then I imported the dataset, which is the iris flower, after I made sure that it is .csv. Take care that sometimes on Kaggle, you have the dataset as .excel or so on. So you must configure if you are going to work as if it's an Excel, or you are going to convert it from Excel to another thing. Okay. Afterwards, we will begin to determine the groups by the median. Do you know why I will determine the groups by the median? Do you have any idea why median and why I will group the dataset? First of all, before doing this question, we have to see the describe of the data. Even though we know that this data is so small, so the description of it won't be that harsh. Okay, we have the mean of 5.84 and the 50% quartile as 5.8. We have the standard deviation as 0.82. We have the spatial width as 0.43. So can anyone tell me what do you think about this observation? Is there any skewness? You can tell from the numbers, actually. So what do you think about these numbers? Is it good? Is it bad? Use your intuition in it. Okay, let's go. We have a count of 150 flowers in the dataset. We have the average sepal length with 5.84 centimeter. The standard deviation is 0.82, which means how the data is spread out, which is the variance. So a small a small STD, and this is a very important observation, a smaller STD, okay, means it is closer to the mean. So let's see, it is not closer to the mean actually. We have 5.84 and 0.82. So most likely the mean here, it is a ring shape, a bell shape. And for the spatial widths, it is also, there is a very far distance between them. Then if we have a large STDs, means that the values are more spread out, that the variance is big. So we can say that the spatial width STD is about 1.76, which is varies more than its width. Then the minimum of the petal length is 1 centimeter. The maximum, you know what. And for the 25% of the data, and for, as we have said, the observations. So let's go on with our exploratory data analysis inside of this data set. After we have done loading the iris, we can know the shape of the data. The shape is from df.shape. df.shape is used to determine the shape of our data. It determines the rows and the columns. We have 5 columns and 150 rows. That's very good. We can say df.isna dot sum to know if there is any missing values that I need to remove, and there is not. Okay. Afterwards, we are going to check the duplicates. The duplicates here is so important. And I mean here the duplicates for the spatial length. Of course, there is some kind of a spatial length matching and a spatial width matching and so on. But it is more important to see the duplication in the species. We have a very you can say we have 3 categories, so we will determine the duplicates from the features. Okay. So you can do 2 things. Either see the duplicates first, or you can drop the duplicates without seeing it. But I don't recommend this. I really don't recommend this. Then we are going to do what? Then we are going to work with the counts. So let's see the counts first. The counts here, we can see only 3, again, species, unique species. So we want to see if the data is balanced or not. So we can do this before seeing the duplicates or dropping the duplicates. So I can do what? I can say df dot value underscore counts to see the values, and here I can determine a specific thing to go with, which is species. Okay. So here we find that our data set is matching, or it is balanced. So I don't think we have to do anything with the duplicates. So next, we will begin to visualize to make sure that everything is okay. For the visualization, I will be using matplotlib and Seaborn. So I have to import, okay, here I have to import Seaborn as CNS. Then we are going to use our very first visualization, which is the counterplot. Okay, so I will say cns.count counterplot according to the species and the type of the data, and data is the df. And it will take some time to run. And here are our visualization. We can see that they are all matching and there is nothing unordinary. Go on.
Excuse me, just
It's still showing the Kaggle, not the VS Code.
What?
It's still showing the Kaggle file, not the VS Code file.
You can
No,
refresh it.
I guess it's VS Code. There's something wrong
Yeah.
with it.
Yeah, I have shared it again. Can you see it now? I have, since Marwan told me, I have switched it to VS Code. So I can do something else. I can stop my share and I can share it again. So if anyone has an error, you can see my screen again. Here you go. So is my screen observable to all of you?
Yes, I guess.
Okay. Okay, perfect. So after visualization, this visualization, you can use it as plt.histogram or hist, and you'll see the same visualization for species and so on. Afterwards, we are going to use the scatter plot. Since we have 3 categories, so I need to differentiate and see if there is a relation between the categories, if there is not, and so on. So I will use Seaborn cns.scatter plot, and I will use the spatial length as the x, and as the y, I will use the spatial width. And I will use different hues, and I will say df. Here you go. You can see the correlation between the data. So you can see here that the iris versus color is the same or have a correlation, a very big correlation between iris versus or something like this. You can see here the correlation as they are together with each other, and you can determine the relationships. You can determine the average. You can determine if there is an outlier or something. Do you think there is an outlier in this data set? Go on, George.
I think the blue point at the left bottom.
The blue point at the left bottom. This one?
Yes.
This one? Look,
Yes.
you can say it is the beginning of the data, because if you come up, you can find some other blue points here. So we can say that the beginning of the spatial length from 1 centimeter and then ranges from 1. There is only 1 point as a 1 centimeter for the spatial length or the sepal length, and you can find it as a 3 centimeter width. So I don't think it's an outlier. Ala, go on.
Yeah, I think there's no outliers here because the data looks like it's related to each other somehow.
Yes, perfect. Okay, and we will know more about this. We can use here again the pairplot, and I think it will give us a better visualization of what is happening here according to the species that we have. Okay, here it is loading, and here is our data. We can see that the sepal length with the sepal length, so it is sure that it has a correlation between them. Then the sepal width with the sepal length. This is a visualization that we have made. We can see here the petal length with the sepal widths. We can see they are already categorized here according to sepal widths. So there is no correlation. You can say there is a very high correlation here, as the dataset is already categorized. Sepal length with the petal width. Here we can see some correlations. So you have to use again your intuition and begin with it and determine the relations. So we have determined many types of relations from the boxplot, as the species has Setosa has the smallest of the petal widths. So let's go to the petal widths. here, and we have setosa here. From where did I have known? I have determined that the blue point is setosa. So we can see here, yes, it has the smallest petal width. Here, look. Here, 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 here. It has the smallest petal length, and petal width, actually. And we can determine more information from the histograms, and I will leave it to you to make, and I will leave the more visualizations to you. Okay. And I think you can use the box plot, you can use anything inside of it. So let's get back to our slides for the very last time, and I will leave you with the tasks of completing ADA for visualization for the iris and EDA for Titanic dataset. For feature engineering, and which is the last thing that we are talking about, and the PCA analysis, feature engineering is one of the most important things that we are going to use. Feature engineering means generating new features from the pattern we have known. So if you didn't determine the patterns right, you won't generate a useful features for the data, and it will be a burden on the model. So we can see the feature creation is about making a new feature to improve the model performance, combine height and width to make a BMI, or combining the score with the IQ of the person to determine more how does this affect the feature selection. Choosing the most relevant features. Most relevant features here, I mean the most features that affects the data, and this is determined by the two ways that we have said, the statistical and the visualization. Removing any redundant data, noisy data, simplify the model, and improve the performance. We can say, what is a feature? A feature is a measurable property or a characteristic of a data that can help the model to make better predictions. And for more complicated data sets, rather than Iris and Titanic and so on, you find that it's a must to do a feature engineering to describe more what is a feature, to describe the relations, to generate more relevant features. And for the feature creation, feature engineering is a process of selecting, again, select, create, and modify the features that helps the machine model to determine the pattern. So it can be feature creation, it can be transformation, extraction, selection, and scaling. Is there any questions till now? Thumbs up if there's.
Yeah, can you give an example for feature transformation?
Feature transformation, it is about transforming a feature from one thing or one version to another. This can be used to, let's say, in images, most likely. It will be used in images. So I can transform a feature to another one. Or I can transform an image to another image with different colors. So this is the idea actually of feature transformation, and what I can say, we are not using it a lot. So feature transformation, it is changing the format from colored scale to grayscale, white and black. The distribution, we can change the distribution of the feature as making it from a skewed to a normal or a bell-shaped. Transforming feature often used with skewed data, different scales, categorical, non-linear, non-model friendly, and so on. So when transforming the data from one type to another or from one form to another, it will be easier to learn, more stable, more accurate, and so on.
Yeah, I
Then
can.
we are going to talk about encoding categorical data, and this is one of the most important features. Categorical data makes to us, you can say, some kind of a hassle in the model. So one of the most important things is encoding it. Encoding it here means transforming the words into a number. So if I have a male and female, I can use a label encoding. Label encoding turns the male to 1 or female to 0, or female to 1 and male to 0, according to what you determine. So if we have only two categories, right and wrong, left and right, male and female, and so on, most likely I will use categorical data and determine one feature to transform it to a form, and the other will be transformed to its version. As I have said, in the data, it is non-negotiable, or you don't have an opinion. We all being to it. One hot encoding, and it is about using categorical data for more than one feature. So if I have 3 colors, red, blue, green, most likely I cannot make the data as 1, 2, 3, 4 for each category, but I can make a column called red and make any row that have a property of red for 1, and all of the others is 0. For blue, the same, and for green, the same. And feature scaling. Sometimes out so bad again, and sometimes it is very useful. So if I'm going to feed a model the outliers, sometimes it is going to make very significant errors. So we can say if the income is from 0 to 1,000, so significant range between 0 and 1,000. So most of one of the common things is scaling the features for tight range, so the model can see the pattern more, improving convergence performance for the algorithms like gradient descent, and I will talk about it soon, or I will send a video about it. Common methods is standardization. Standardization is transforming all the values from 0 to 100,000 to numbers between 0 and 1. Many max scaling, it is a fixed range, usually 0 and 1. Then last thing we are going to talk about is the PCA, or the dimensionality reduction. Do you have any questions till now? Okay, let's go on. The dimensions in machine learning is determined by how many features do we have. The features determine the dimensions. So if you have a data set that have 10 features, so it have 10 dimensions. So it becomes hard to interpret, visualize, and make the model from it will be very hard. So one of the most useful ways is to remove the irrelevant features and make a feature engineering to the other features, either scale, either transform, either having a new version of this data to make it more efficient for the model to see the patterns. Because as you have more features, as the model become more complex. Why do we use a dimensionality reduction or reducing dimensions? Actually, it does not mean it don't necessarily mean more useful information. They can make learning harder, it can hide patterns. The dimensionality here helps to simplify the data, detect the pattern more clearly, and make it in a most meaningful structure. So PCA is one of the most useful things to do. It is called principal component analysis, and it's a technique used by sklearn and many other things. You can search about it with many features, okay, into a new set of features called the principal components, and this is the components that I will build the model on. It summarizes most of the original information into fewer dimensions. So from the 10 features that I have, I can summarize it into 5 dimensions. It finds the directions where the data varies the most. The first principal component captures the largest possible variance as the spread of the data. Second principal component captures the variance while being uncorrelated, unmatched, or unrelated to each other. So this is why we use PCA. And that's it. And I will send you the data to complete it. And I will wait to the assignments and I will upload all of the assignments on the classroom. And I will provide the code for PCA if anyone need it, you can see. I will provide more code about how to do feature engineering. And that's it. Is there any questions?
Okay, so the
Go on.
requirements will be specific and detailed, or we have to figure out.
Sorry, I
what we-
can't hear you. Give me a second.
Yeah, you can hear me now.
Okay, can you tell me now what is the problem?
You can hear me?
Yeah, I can hear you now.
Okay, so I said like the requirements for the assignment would be specific and detailed, or we have to figure out what we gonna do, or you know.
No, I will give you the problem and I will tell you what do you need to approach in each statement, and you can go with the steps as you want.
Okay, so
of the model. Yeah, go on.
yeah, so the deadline will be 1 week or less than this.
Yeah, 1 week.
Okay, last question. Can you share the material of PS2 that you have here? Like, I need
Tell me again, please.
Can you share the material that you? Yeah.
Yeah. All of the material will be uploaded maximum next morning on the classroom.
Okay, take your time. Thank you.
You're welcome. Is there any questions? Okay, let's read the chat. There is something in the chat before we go. Thank you so much for all of you for joining us today, and I will be happy to hear from you again, and I will be happy more to receive your feedback about the session and about the content that we have provided. And thank you so much again for joining, and see you next week. Bye.